Hello children. Today we talk about IUPAC naming of organic compounds. So this is the last step in nomenclature of organic compounds. Again, I will remind you that most of the rules will be same as we discussed earlier. So let us start with organic compounds or benzene ring containing compounds. This is benzene. You all know well. This is the resonance hybrid of benzene. It may be written in this form or may be written in this form. Means the position of pi bond in benzene is not fixed. It's not localized. This is delocalized. Means equally distributed all around the benzene ring. So all other derivatives of benzene are written by taking benzene as main chain, and then we write the names of derivatives or functional groups. Like if I start with a very simple case, this compound. The substituent present in the side chain of benzene is methyl. So the name of this compound is methyl benzene. If ethyl is there, we may write ethyl benzene. In this way, you can write the name. But in aromatic substances, beta, the common names are very popular. Even they are more frequently used as compared to IUPAC nomenclature. So that's why it's very important for us to learn the common names of aromatic substances. Like for methyl benzene, its common name is toluene. Its common name is toluene. So we have to learn this name. It is even more frequently used as compared to methyl benzene. For example, any chemical reaction is given and it is given that the reactant is toluene. So if you don't know this name, it becomes impossible for us to write that chemical reaction. That's why I'm saying you have to learn all these common names. Wherever required, I will tell all the names for aromatic substances. Right, beta? Now the next one is, if we take this one, inside chain, we have taken halogen. So for halogen, we use the prefix halo. That's why the name of the substance is chloro. Then the main chain is benzene. Chlorobenzene is its IUP. Yes. Now I think you can easily write IUPAC names of all these compounds which I gave. Like in first case. First of all, we need to check the numbering order. Should we give first position to this carbon or first position to this one? Beta, the rule says, first rule is try to give minimum possible number to the substituents. Now in this case, substituents are taking first and second position from both the ends. So the second rule says, if positions are same from both the ends, then give minimum number to the substituent which alphabetically comes first. So now we prefer ethyl end, not the methyl ones. So in this case, the numbering is in this order. This is. Now write the substituents in their alphabetical order. So this one is 1 ethyl, 2 methyl, and then main chain, that is benzene. 1 ethyl, 2 methyl, benzene. Right? Coming to the next one. Both are methyl groups and present at first and second position. So simply we may write 1, 2, then for 2-methyl we write dimethyl benzene. Right, beta? Coming to next one. Here this is methyl group is present on first and third position. So we write 1,3 dimethyl benzene. This one becomes 1,4 dimethyl. 1,4 dimethyl benzene. Now the next very important point is, while writing common names for first and second position, ortho prefix is used. What do we write for first and second? Ortho. So in common names, the substance is termed as ortho dimethyl benzene. Rest of the name remains same. Only at the place of first and second in common names we use the position as ortho. So this O stands for, it stands for ortho. So beta here I am writing the positions in benzene. This is for benzene ring, aromatic compounds only. Don't use this for aliphatic compounds. So for first and second position we use ortho. For first and third we write meta. First and fourth we write para. Clear? And these are abbreviated as O, ortho, M for meta, P for para. So similarly this compound, CH3 group is coming at first and third. So the common name of this compound would be, at the place of 1,3 we will be writing meta. So this is termed as meta dimethyl benzene. Same here. This is first and fourth position, and first and fourth in common name written as para. So common name of this compound is para dimethyl benzene. This compound, first check the functional group present on benzene ring, because the most important thing is to identify the functional group. Any idea or getting confused? Beta, this is benzene ring. Means simply we can say at the place of alkyl group, this is aryl group. Single bonded oxygen. Again this Me. Me stands for methyl. Wherever Me is written, means this is methyl, CH3. Et is written, means C2H5, ethyl. Clear, children? So this is OCH3. So remember, ROR is ether functional group. So functional group present here is ether. Now for ether, this group is methoxy group, and methoxy group is bonded with benzene ring. So name of this compound is methoxy benzene. What is its name? Methoxy benzene. More commonly named as anisole. Very, very important name, anisole. So if it is written, draw the structure of anisole. Immediately it should come in our mind that anisole means methoxy benzene. Clear, beta? Then next one, NH2 group is present on benzene ring. We know suffix for NH2 is amine. So simple, name of compound is benzene amine. IUPAC names are really very simple to write if we remember all the rules. So this one is benzene amine. But again, very important to learn the common name, termed as aniline. Benzene amine is termed as aniline. Again, very important name. Mostly for benzene amine, you will find in books aniline is written. Then this compound, benzene ring, which functional group is there? NO2. And we know for NO2 there is no suffix. NO2 is treated as substituent, and the prefix used for NO2, remember children, that is nitro. So name of this compound is nitrobenzene. This is nitrobenzene. Coming to this one, we know two substituents are there. Total 3, but 2 types of substituents are there. One is chloro and the second and third both are nitro. Now question comes, the most important question here is numbering sequence. Beta, check from every side whichever sequence gives minimum possible number to the substituents. We will prefer that sequence. Just discuss with me. If I am giving first number to this carbon, 1, 2, 3, 4. The substituents are coming at first, third and fourth position. 1, 3 and 4. Check another option. 1, 2, 3, 4. Right, beta? 1, 3, 4. And this direction is 1, 2, 4. If you remember, we discussed we have to check the first point of difference. Wherever we get the first point of difference, just stop there. At second position, we are getting the difference. First position is same, 1 in both the cases. But here the second position is 3 and here it is 2. So we will go for 1, 2 and 4. Because and one more option we have, we can check. We may start from here. If we are starting from here, this is 1, 2. These two sides are same. But 3, 4, 5. Third position is fifth one. So, of course, the correct option is which position? This is 1, 2, 3 and 4. So, now simply give numbering 1, 2, 3 and 4. And now while writing the name, arrange the substituents in their alphabetical order. So, name of this compound would be 1-chloro. Second and fourth, both nitro. So, 2,4-di-nitro, and this is benzene ring. Clear, beta? So, I think now you understand this name, 1-chloro, 2,4-dinitro, benzene. For all these cases, up to here at least, beta. Now, my instruction is just pause the video, write the names on your own and then come back and compare your answer which I am explaining now. So please everyone do this and I hope you will follow me. So just start the numbering. The first option 1, 2, 3, 4 means 1, 3, 4 option is coming with me. Just check the next one. This side 1, 2, 3, 4. No chance. Next option, if I select this as first, this is 1, 3, 4. 1, 3, 4. Right? But if I'm starting from this point, 1, 2, 3, 4. 1, 2, 4. So, beta, of course, I will go for 1, 2 and 4 positions. So, if you have done this, you are absolutely right. Because nitrochloromethyl, all three are treated as substituents. And if all these three are treated as substituents, we have to check the minimum possible position, that select the and which give minimum possible positions. So, this is the numbering sequence now. Now, arrange them in alphabetical order. This is methyl, chloro, nitro. First of all, we write chloro. This is 2 chloro. Then 1 methyl. Nitro is at 4th. 4 nitro benzene. Yes, beta. I think now you are more confident to write the names of all these compounds. Coming to next compound, beta, how do we write the next compound? Check the groups present. O and E. Now it is clear. This is ether, chloro, methyl. And ethers are named in terms of derivatives of anisole because methoxybenzene is named as anisole. So beta, this is clear that now this compound is this one. This is anisole. So of course I will be writing this as the derivative of anisole. And if I am writing this as derivative of anisole, so of course this is the numbering order 1, 2, 3, 4. 2 chloro 4 methyl. So name is 2 chloro 4 methyl. Then this encircled part is termed as anisole. Understood, beta? What is the importance of these common names? Even accepted by IUPAC here. Because this is written as derivative of anisole. Similarly, this one, just check children, derivative of aniline. So this part is aniline. This one part is aniline. Now we write the name in terms of aniline. So of course this is first position, second, third, fourth. Write the substituents in alphabetical order. So it is 4 ethyl, then 2 methyl, and then the complete name is aniline. Done? Coming to next. In next case, benzene ring is bonded with OH. In aliphatic compounds, beta, how do we write the names of these compounds? After alkane, we use suffix ol. Yes or no? We write alkane, that is main chain, and then we use the suffix for alcohol, that is ol. But in benzene or aromatic compounds, we will not follow this rule. Because according to IUPAC, whenever OH group is present on benzene ring, this compound is named as phenol. What do we call it? Phenol. This is phenol. All others are treated as derivatives of phenol. Like these are derivatives of aniline, derivatives of anisole. So similarly, this is derivative of phenol. Now you please try the name of this compound on your own and then come and check with me. So this is first position for phenol group, OH group. So now the name is 3,4-dimethyl. 3,4-dimethyl, and then the principal chain is phenol. Okay, beta? Now we have completed all the rules of nomenclature, discussed all different types of compounds. Here I have given you some mixed examples where we are trying to cover aromatic, aliphatic, unsaturation, functional group, cyclic compound. All these things we are covering in these examples. So just try these examples. Once again my instruction is try on your own and then check your answers. So this is one revision. First of all, beta, in this case we have to decide main chain because here simple straight chain of carbon atoms is also there as well as benzene ring is also present. So which should be the main chain, benzene ring or the straight chain of carbon atoms? So beta, the rule is very simple, says we should select that chain which include functional group. And functional group is coming in straight chain, then of course we will go for the straight chain. So now it's a chain of 1, 2, 3, 4, 5 carbon chain. In this 5 carbon chain, substituent is present on 4th position. But one more thing I need to tell you, that whenever benzene ring is coming in the form of substituent, means one hydrogen is removed from benzene ring. This is one hydrogen is removed. So it is bonded with the main chain. This group is C6H5 is its molecular formula, and name of this group is phenyl. So whenever benzene ring comes in the form of substituent, we write it as phenyl. So phenyl is present at 4th position. So name of this compound is now 4-phenyl. 5 carbon chain, pent. For double bond ene, that is on 4th position, 4-ene. And for aldehyde, the suffix is al, 1-al. Your choice, whether you are writing 1 or note, both are correct. Next one, main chain containing functional group, that is carboxylic acid, 1, 2, 3, 4, 5, 6, 7. Again benzene ring C6H5 group, that is phenyl group. So it is present at 5th position, 5-phenyl. 7 carbon chain is hat. 3-ene, 6-ine. Write in alphabetical order. 3-ene, 6-ine. Don't use these E. 1-oic acid or simply oic acid. Coming to this one, functional group alcohol is there. So we give first carbon to that carbon which contains functional group. So this OH containing carbon carries first position, right? 1, 2 carbon chain. On second position, 2 chlorine present. So this is 2,2-dichloro. 2 carbon chain is eth, single bond ene, suffix of alcohol is ol, 1-ol or ethanol. This one beta, I'm sure many of you have selected wrong chain here. Why wrong chain? One thing is very much clear, we will go for this chain because we cannot go for benzene ring as a main chain because functional group is coming in this. But the mistake which generally students do is, so if I start counting from this point, this is 1, 2, 3, that's it. They will stop here. But no, chain is going in this direction, 2 carbon are there. Don't take ethyl as substituent. Ethyl is not a substituent. This is in continuation with this chain. So be very, very careful while selecting the main chain. So this is now 4 and 5 carbon main chain. In this 5 carbon main chain, at 3rd position we have 2 phenyl groups. So the name is 3,3-diphenyl. Then 5 carbon chain is pentane, 2-ol. Pentane, 2-ol. Done? Coming to this one, seem to be very difficult. No, not difficult. It becomes easy if we open this chain, expand the chain. Because here this is written in condensed form. So first you have to expand the chain. So how do we expand? Just check beta, this carbon is bonded with 2 CH3. Give 2 CH3. Then this is bonded with 2 CCl3 groups. So 2 CCl3 groups are present here. Now we select, after expanding this was condensed formula. So after expanding, now we select the main chain. Just check how many maximum carbon? 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. In any direction you will go. From each and every direction we will be getting 3 carbon chain. Now, whenever we have more than one chains of same length, what is the rule? Remember, rule says select that chain having maximum number of substituents. So now follow this rule, select the chain. If I am selecting this straight chain, it has how many substituents? 1 and 2 substituents are there, right? Second option, if I am selecting this chain, again I have how many substituents? This is the chain. If we selected, this is first 1, 2, 3, only 2 substituents, 1 is here, second is here. But if I select this chain beta, 1 substituent is here, second is here, and 3 are on this carbon. First carbon no substituent, second carbon 1 and 2 substituent, and third carbon 3 substituent. Means total 5 substituents are there in this chain. Understood beta? Coming to next option, I have one more option, 1, 2, 3. If I select this chain beta, 3 substituents on first carbon, 2 substituents on second carbon, and 3 substituents on third carbon. 3 plus 3, 6 plus 2, 8. So means this chain has maximum number of substituents. So of course now we will go for this chain. Don't go for this one or this one. Whenever we have more than one chains of same length, always select the chain having maximum number of substituents. So this is our main chain. Now write the substituents in alphabetical order. 2 types of substituents, methyl and chloro. So of course chloro will come first. 3 chloro on first carbon. So it is 1, 1, 1. 3 chloro. 3 chloro on third carbon. So write the position. 3, 3, 3. And for 6 chloro we write hexachloro. Hexachloro. On second position 2 methyl. So 2, 2 dimethyl. And 3 carbon chain propane. Become simple after expanding the chain and following the rules. This one. Main chain cyclic or open? Open because open chain has functional group although the length is small. But it contains functional group. So open chain is our main chain. Select this chain 1, 2, 3. Second position cyclobutyl is there. So 2 cyclobutyl, 3 carbon chain, propane suffix for aldehyde al, 1 al or propanol. So now last part of nomenclature is writing formulas from given names. In all previous lectures we talked about how to write the names of given compounds. But now we will be writing the formula for each compound. Like 2-amino-ethanol. Whenever we have to write formula, we will always start with main chain. Select the main chain first of all. Like here, it's a 2 carbon chain, eth. So first select the chain, 2 carbon chain, 1, 2. Then we write the functional group. That is, ol is present on, of course, first position. Because whenever position is not given, understood this is first position. So if I am selecting this carbon is first, you may select this even from any direction we may start. So OH on this carbon, and at second position amino means NH2 group. This is the prefix for NH2 group. So on second carbon write NH2 because we have started numbering from this end. So complete. Now this formula is written, but now give hydrogen according to the free or unsatisfied valency of each carbon. Like for this carbon, 2 valences are unsatisfied. Same here also 2 valences are unsatisfied. So give 2 hydrogen to each carbon. This is the way to write formula. Just start with this one. Again, first of all, as I told you, select the main chain. Children, please in this complete name, check where is main chain. Word root. Like 5-ethyl 4-methyl. Prefixes non. Yes, this is our main chain. Non means main chain contains 9 carbon. So take a chain of 9 carbon. But you may write the simple chain in this way, or you may write the chain in the form of bone line. After selecting the chain, beta give numbering to the chain from any side. You may start now because this is a very simple chain, from left or from right. Like I am giving numbering 1, 2, 3, 4, 5, 6, 7, 8, 9. So now this is my 9 carbon chain. Now once you give numbering to the chain, it becomes very easy to place the substituents, because at that specific position, place that substituent. Like here, at 4th position we have ethyl. So give C2H5 group or simply in this way. Your choice, beta. 4th position, methyl. So 1 carbon group on 4th position. Then non-4-ene at 4th position, double bond is also present. So this is 4th carbon, this one. So give a double bond to 4th carbon. Then oic acid, of course at 1st position. So whenever position is not given, understood first. So this is COOH. Easy? Coming to this. Orthoethyl anisole. Yes, beta, as I told you, in organic compounds, generally questions comes in terms of their common names. They haven't written methoxybenzene. It is written anisole. So if we know methoxybenzene is anisole, then question becomes very simple for us. So first is anisole, that is methoxybenzene is anisole. Now to this methoxybenzene, give the group orthoethyl. Ortho means which is second position. So at second position gives ethyl group, C2H5. Done? Next one. First of all, select the main chain. 4-ethyl, 1-fluoro, 2-nitro-benzene. Here comes our main chain. So this is benzene. Now give substituents. First is fluoro, F. Children, again as I told you, give the numbering so that becomes easy to place the groups. 4 carbon. First is 4th position is ethyl. So at this position gives C2H5. Then 1 is fluoro already placed. At second carbon, nitro, that is anode. Complete. Next, diethyl ether. Here again they have asked the question in terms of common name, not in terms of IUPAC name. So first identify the functional group which is there. Ether. Formula of ether is ROR. Yes, remember what is this ether group? ROR. Both sides we will be having chain of carbon atoms. So first write this ether group. Then both sides write the chain of carbon atoms. Ethyl means it's a chain of 2 carbon. So C2H5, C2H5. Or you may write CH3, CH2, O, CH2, CH3. Means we may write in this form. Both ways are correct, beta. Or you may use bone line notation even. It's your choice. This one. Cyclopentine. So this is our main chain. Right now, here comes our main chain. That is of pent. Pent means 5 carbon chain. So select a chain of So this is my 5 carbon chain. After selecting chain, what to do? Numbering to that chain so that we can easily place the groups in that chain. So from any direction we can start. 1, 2, 3, 4, 5 carbon chain. I have selected the numbering also. Now sorry beta, sorry. This is not, na? Cannot. Why? Because cyclopent, I haven't paid attention here. I simply check the main chain. Cyclopent means this is a ring of 5 carbon, not straight chain. So, this one, 5 carbon ring. Now, in this 5 carbon ring, cyclopent, it's done. Then ine. Ine means triple bond. Anywhere you can give triple bond because all the positions of cyclic compounds are same. So, you give triple bond at any position. This is cyclopentine, or you may make it more neatly like this. Clear? This is cyclopentine. So this is all about writing names as well, IUPAC as well as common name, and the formulas of organic compounds. So now children, when this, all the rules for formula writings, nomenclature for all different kinds of compounds, that is completed. So now it's your turn now. Practice as many as compounds you can do. But beta, one thing keep in your mind that very complicated chains, they are generally not asked in exams. In terms of very simple chains, examiner will confuse you by giving that in the either in the form of bold line notations or including more than one factors in the same chain. So don't worry about very long or complicated chains. Even in very small chains, you can practice all the rules like we did in previous cases. So it's okay beta. Now practice for nomenclature.